Find out now. The top 100 science questions still unanswered. Spoken slowly, like a late-night guide through a universe that keeps its secrets. We've learned so much. Telescopes have traced the faint glow of the Big Bang, particle accelerators have plumbed the heart of matter, and probes have whispered the stories of distant worlds. And yet, 100 puzzles remain. Tonight we'll move through them gently, 10 sets of 10, from the cosmos's first breath to the flicker of thought inside a mind. Unanswered here means either an empirical gap, something we have measured but not explained, or a deep theoretical puzzle that resists our best ideas. Some entries point at instruments that might help, others at experiments or new mathematics. Many are speculative by nature, and I will label them so when needed. We begin with the largest questions, cosmic origins and fate. Imagine standing at the shoreline of everything and listening to the long, patient tide of inquiry. 1. Why is there something rather than nothing? We can describe how the universe behaves, from quarks to galaxies, but physics starts with the fact that something exists at all. The mystery: why is there any physical reality instead of nothing? Philosophers and physicists offer ideas, from quantum fluctuation models to metaphysical frameworks, but none provide an empirical answer. Why it matters? This frames every other question about origin and explanation. Probing it shapes how we think about cause and existence. Poetic tie? It is the deepest hush before the first note of the cosmos. 2. What triggered the Big Bang? Observations like the cosmic microwave background, measured by Planck, tell us the universe was once hot and dense, then expanded and cooled. The core unknown: what event or process initiated that initial hot, dense state, and was there anything before it in a meaningful sense? Why it matters? Resolving this would reshape our picture of time and causation. Poetic tie? It's like asking what struck the match that became the dawn. 3. How did cosmic inflation start and stop? The inflation idea, a brief epoch of extremely rapid expansion, explains the universe's large-scale uniformity and the seeds of structure, and some predictions match observations. The mystery: what physical field or mechanism caused inflation, and how did it end so cleanly in a hot Big Bang? Why it matters? Inflation links quantum physics and cosmology. Finding its origin would connect the very small and the very large. Poetic tie? Inflation is the universe's brief, furious exhale, whose origin we still can't read. 4. Why is the arrow of time directed? Thermodynamics tells us entropy increases, giving time an apparent direction, and cosmic expansion sets an overall arrow. The mystery: why were the universe's initial conditions so low in entropy that time appears asymmetric? Why it matters? This question ties cosmology to the foundations of physics and to why causes seem to precede effects.
Poetic tie. It is the reason stories have beginnings and endings. What is the ultimate fate of the universe? Measurements suggest accelerated expansion driven by dark energy, observed through supernova surveys and the cosmic microwave background. The unknown: will expansion continue forever, tear structures apart in a big rip, halt or reverse someday under different physics? Why it matters: the fate of the cosmos affects long-term astrophysical evolution and philosophical perspectives on permanence. Poetic tie: a horizon stretching farther and farther, or a slow dimming like a lamp fading. Why are the fundamental constants finely tuned? Constants like the cosmological constant and the strengths of forces take values that allow stars, atoms, and chemistry to exist. The puzzle: are these values determined by deeper laws, set randomly across many universes, or the result of selection effects? Why it matters: this question challenges ideas of necessity and contingency in nature and bears on the possibility of a multiverse. Poetic tie: the cosmos balanced on a knife edge where small changes would erase possibility. Is there a multiverse, and can we ever test it? Some models of inflation and quantum gravity suggest many pocket universes with different properties, a multiverse, but direct evidence is lacking. The issue: how could we empirically verify or falsify such a hypothesis, and what would it mean for scientific explanation? Why it matters. It affects whether fundamental parameters need deeper causes or are environmental. Poetic tie. Perhaps our universe is a single bubble in a boundless sea, but the sea may be forever out of reach. Where do the cosmic initial conditions come from? Cosmology uses initial data to evolve the universe forward, but the origin of those initial conditions remains unexplained. The mystery. Are initial conditions themselves governed by a law, or are they a brute fact? Why it matters. Answering could change whether cosmology is complete or always contingent. Poetic tie, like asking who set the first domino into place. What is the true nature of time? Time appears continuous and ordered, but quantum theories and relativity treat it differently. Some approaches suggest time might be emergent for more fundamental relations. The unresolved point. Is time a basic ingredient of reality or a derived concept arising from deeper timeless structures? Why it matters. It would reshape the foundations of physics and our sense of change. Poetic tie. Time could be a river or a pattern woven into the fabric itself. Are the laws of physics unique or variable? We use fixed laws to make predictions, but some frameworks allow laws that evolve or vary across space-time. The open problem. Do physical laws have permanence, or might they change over cosmic history or within different regions? Why it matters. This bears on predictability, the universality of physics, and how we interpret physical necessity.
Poetic tie. Whether the rules are carved in stone or written on sand by an unseen tide. If these early questions make your mind wander into the quiet, like a telescope on a clear night, and you'd like more slow voyages like this, consider liking or subscribing. It's a small way to join the patient search. Leaving the very concept of the cosmos for what fills it, the next 10 questions press at the dark components and the foundations of matter. 11. What is dark matter made of? Galaxy rotation curves, gravitational lensing, and cosmic structure point to unseen mass we call dark matter. The unknown. Is it a new particle, a composite object, or a failure in our gravity models? Why it matters. Dark matter shapes galaxy formation and cosmic structure. Discovering its nature would complete our inventory of matter. Poetic tie, an invisible scaffold holding galaxies like lantern frames in the night. 12. What is dark energy and why does it drive acceleration? Measurements, including supernova surveys and Planck's observations, show the universe's expansion accelerating, attributed to dark energy. The puzzle. Is it a cosmological constant, a dynamic field, or a sign of modified gravity? Why it matters. Dark energy determines cosmic destiny and points to physics beyond the standard model. Poetic tie, a gentle wind pushing galaxies apart, its origin unknown. 13. Why is gravity so weak compared to other forces? Gravity is far weaker than electromagnetism or the strong force at particle scales. This hierarchy is puzzling. The mystery. Is there an underlying mechanism, extra dimensions, symmetries, or new particles explaining the gap? Why it matters. Solving it could reveal new structure beyond known forces and connect to quantum gravity. Poetic tie, like a whisper against thunder in the symphony of forces. 14. Can we reconcile quantum mechanics and general relativity? Quantum theory and Einstein's gravity both succeed where tested, yet they are incompatible at short distances and high energies. The question, what is the correct theory of quantum gravity, whether string theory, loop quantum gravity, or something else? Why it matters. A unified theory would let us describe black hole cores and the universe's origin. Poetic tie, the meeting point where the very small and very vast finally bow to one another. 15. What is the nature of the Higgs field and its fine-tuning? The Higgs boson gives elementary particles mass, yet its measured mass raises questions about naturalness and stability. The unknown, why the Higgs mass sits where it does, and whether additional physics stabilizes it at higher energies. Why it matters. This ties to the hierarchy problem and possible new particles accessible to colliders. Poetic tie, the fabric that dresses particles, its pattern both delicate and mysterious. 16. Do extra dimensions exist? Some theoretical frameworks suggest dimensions beyond the familiar 3 of space and 1 of time.
The central uncertainty. If extra dimensions exist, why are they hidden? And can they be detected via colliders, gravitational waves, or cosmology? Why it matters. Extra dimensions would change our understanding of space and could explain force strengths. Poetic tie. Hidden corridors behind the walls of our perceived room. 17. What causes neutrino masses and their strange mixing? Neutrinos are tiny, nearly massless particles that oscillate between types, a phenomenon established by experiments. The question, what mechanism gives neutrinos mass? Is it the same as other particles? And are neutrinos their own antiparticles? Why it matters. Answers could illuminate physics beyond the standard model and the matter-antimatter imbalance. Poetic tie, ghostly dancers switching masks in the dark. 18. Why is there more matter than antimatter? The observable universe is dominated by matter, despite theories suggesting matter and antimatter should have been created in equal amounts. The unknown, what processes in the early universe generated this asymmetry? Why it matters. Understanding baryogenesis would link cosmology and particle physics and explain why you exist instead of annihilation. Poetic tie, a faint tilt in the cosmic coin that favored one side. 19. What are the limits of the standard model? The standard model explains fundamental particles and forces except gravity, but it leaves phenomenon unexplained, dark matter, neutrino masses, and more. The issue, what lies beyond its structure, and which experimental signatures will reveal new physics? Why it matters. Extending the model could unify disparate puzzles and suggest new principles. Poetic tie, the current map shows the coastlines, but the ocean beyond remains dark. 20. Is spacetime discrete or continuous? Some quantum gravity proposals suggest spacetime may be granular at the smallest scales, while classical physics treats it as smooth. The core unknown, do we reach a minimum unit of space and time, and can experiments probe it indirectly via high-energy phenomena or gravitational waves? Why it matters. Discreteness would change how we think about locality and causation. Poetic tie, whether the world is woven from threads or painted in a continuous wash. Now we turn from the foundations of particles to the most extreme objects in the universe, black holes, and the violent astrophysics that bends light and matter. 21. What happens at a black hole singularity? General relativity predicts singularities where density becomes infinite, but the theory likely breaks down there. The mystery, what truly happens inside the deepest core of a black hole when quantum effects are included? Why it matters. A resolution would connect gravity and quantum mechanics and clarify the fate of collapsing matter. Poetic tie, the center where known laws fold inward like a closed book. 22. How is information preserved in black holes?
Hawking predicted black holes emit radiation and may evaporate, raising the information paradox. Does information about infalling matter vanish or survive? The unresolved point, what mechanism reconciles quantum unitarity with black hole evaporation? Why it matters? It tests the consistency of quantum theory and gravity. Poetic tie, whether stories swallowed by darkness leave any trace in the ash. 23. Can we detect Hawking radiation? Hawking radiation is an extremely weak quantum emission from black holes, never observed directly around astrophysical ones. The question, are there observational or laboratory analogs that could confirm this prediction? Why it matters, detecting it would be a rare probe of quantum gravity effects. Poetic tie, like catching a whisper from an otherwise silent furnace. 24. How did the first stars in black holes form so early? Observations from telescopes like James Webb reveal surprisingly massive galaxies in black holes at early times. The puzzle, how did these objects grow so quickly within a few 100 million years after the Big Bang? Why it matters, it challenges models of structure formation and may reveal new physics or unusual early conditions. Poetic tie, the universe's first great lights switching on earlier than we expected. 25. How did supermassive black holes become so large so fast? Quasars powered by billion solar mass black holes appear when the universe was very young. The unknown, did they form from direct collapse, rapid mergers, or unusually efficient accretion? Why it matters, understanding their growth informs galaxy evolution and early cosmic history. Poetic tie, colossal engines revving up at the dawn of time. 26. Do event horizons behave as classical boundaries? Event horizons are the surfaces beyond which light cannot escape, but quantum effects may alter their behavior. The open question, could horizons be replaced by more complex structures like fuzzballs or firewalls, as some theories suggest? Why it matters, altering horizons would change how we model black holes and information flow. Poetic tie, is the shore hard and final, or a misty edge with hidden currents? 27. Are there traversable wormholes or shortcuts through spacetime? General relativity allows mathematical solutions resembling tunnels, but they typically require exotic matter or violate energy conditions. The uncertainty, can any physically realistic process produce stable, traversable wormholes? Why it matters, such structures would revolutionize concepts of causality and travel. Poetic tie, dream passages that may exist only in the margins of our equations. 28. What powers the most extreme jets from black holes? Active galactic nuclei launch relativistic jets that travel vast distances, but the exact mechanisms converting accretion energy into focused jets remain debated. The question, how do magnetic fields, spin, and plasma physics combine to launch and collimate these flows?
Why it matters. Jets sculpt galaxies and distribute energy on cosmic scales. Poetic tie, cosmic lighthouses cutting across intergalactic night. 29. How do black holes merge and ring down? Gravitational wave observatories like LIGO and Virgo detect merging black holes, revealing their masses and spins. The detailed unknown, what subtleties in these signals reveal about strong field gravity and potential deviations from general relativity? Why it matters? Mergers were laboratories for gravity at its most extreme. Poetic tie, two titans embracing and then reverberating like struck bells. 29. What is the distribution of intermediate mass black holes? We have strong evidence for stellar mass and supermassive black holes, but objects in the range between hundreds to thousands of solar masses are elusive. The question, where and how common are these intermediate mass black holes, and what role do they play in galaxy evolution? Why it matters? They may bridge formation scenarios for the largest black holes. Poetic tie, the middle stones in a bridge that we can only half see. The sky is full of short, strange signals and furious events. The next set digs into transients, bursts, and particles that flash across the cosmos and leave us asking how. 31. What causes fast radio bursts, FRBs? FRBs are millisecond radio flashes first discovered in recent years, some repeating and some one-off. The core mystery, which astrophysical processes power them, magnetars, exotic collisions, or something more exotic? Why it matters? FRBs probe extreme physics and intergalactic space. Identifying their sources would open a new window on energetic processes. Poetic tie, sudden brilliant footnotes scribbled across radio skies. 32. How do magnetars generate such extreme magnetic fields? Magnetars are neutron stars with magnetic fields trillions of times stronger than Earth's, seen in X-rays and gamma rays. The unknown, what dynamo or collapse conditions produce and sustain these fields, and how they evolve over time. Why it matters? Magnetars test matter under extreme conditions and may explain transient phenomena like FRBs. Poetic tie, magnets so fierce they twist the fabric of nearby space. 33. What accelerates cosmic rays to the highest energies? Cosmic rays, charged particles hitting Earth, sometimes carry energies beyond what particle accelerators can reach. The open question, what astrophysical accelerators, supernovae, active galaxies, or others, produce the ultra-high energy cosmic rays observed by Pierre Alger and others? Why it matters? Their sources reveal the most violent particle accelerations in the universe. Poetic tie, particles flung like pebbles across an ocean of stars. 34. What powers short and long gamma ray bursts? Gamma ray bursts are brief but intense flashes of gamma rays linked to stellar collapse or mergers of compact objects. The details, how exactly do these cataclysms convert gravitational energy into focused gamma emission?
Why it matters? They mark the births of jets and heavy elements and probe extreme relativity. Poetic tie, sudden beacons that flare like cosmic flares. 35. Why do some pulsars glitch unpredictably? Pulsars are rotating neutron stars whose pulses can suddenly change in frequency, glitches, revealing internal dynamics. The mystery, which internal processes, such as superfluidity or crustal shifts, cause these abrupt changes? Why it matters? Glitches inform us about matter at nuclear densities and neutron star interior physics. Poetic tie, an ancient clock skipping a beat. 36. What creates repeating versus non-repeating FRBs? Some FRBs repeat from the same source, while others appear one-off. The question, are these different classes produced by distinct mechanisms or by the same engine under different conditions? Why it matters? Distinguishing classes helps identify progenitors and physical processes. Poetic tie, a single storyteller with a long tail and anonymous flashes that speak once. 37. Where do heavy elements beyond iron primarily form? Elements heavier than iron are produced via neutron capture in processes like the R process, observed in neutron star mergers, and possibly special supernovae. The open issue, what are the dominant astrophysical sites and their relative contributions over cosmic time? Why it matters? It tells the history of chemical enrichment and the source of many rare elements. Poetic tie, cosmic forges hammering the periodic table into being. 38. What causes cosmic void structures and dynamics? Vast regions with few galaxies, cosmic voids, are shaped by dark matter, dark energy, and initial conditions. The unknown, do void dynamics reveal subtle physics of dark energy or modifications to gravity? Why it matters, voids are a clean laboratory for cosmological models. Poetic tie, quiet hollows between the forested clusters of galaxies. 39. How common are exoplanetary magnetospheres? Magnetic fields around planets shield atmospheres and affect habitability, but detecting exoplanet magnetospheres is challenging. The question, how prevalent are strong planetary magnetic fields, and how do they form and persist? Why it matters, magnetospheres help preserve atmospheres from stellar winds and influence habitability. Poetic tie, invisible shields glowing faintly in a stellar breeze. 40. What are the population properties of stellar remnants? White dwarfs, neutron stars, and black holes are the endpoints of stellar evolution, observed in surveys and gravitational waves. The gap, what is the full mass, spin, and binary distribution of these remnants across galaxies? Why it matters, these demographics encode the life cycles of stars and inform models of star death. Poetic tie, the scattered seeds left after a star's long bloom. We leave high-energy skies and drop closer to home, to the planets, rings, and oddities in our own solar system.
The next block explores mysteries on a smaller cosmic stage, where probes like Cassini and Voyager have whispered puzzles into our ears. How old are Saturn's rings? Cassini's observations revealed rapid ring evolution and narrow structures, suggesting they may be younger than Saturn. The central puzzle, what is the true age of the rings? Ancient from formation or relatively young from a recent event? Why it matters, ring age informs planetary history, satellite interactions, and ring dynamics. Poetic tie, a halo that may be a newborn's garland or an ancient crown. Why is Uranus tipped on its side? Uranus spins with an extreme axial tilt, so its poles point nearly at the Sun for half its orbit. The mystery, did a giant impact, torques from many objects, or other dynamical interactions produce this tilt? Why it matters, understanding it reveals violent epochs in planetary system formation. Poetic tie, a planet rolling like a barrel down the solar path. Why does Venus rotate retrograde? Venus rotates slowly and in the opposite direction to most planets, a curious dynamical oddity. The question, what processes, tidal interactions, atmospheric torques, collisions, cause this backward spin? Why it matters, it affects climate history, atmospheric dynamics, and planetary evolution. Poetic tie, a slow spin like a dancer turning to face the past. How extensive are subsurface oceans in icy moons? Enceladus, Europa, and other moons show evidence, via Cassini and future missions, of subsurface liquid layers beneath ice shells. The unknown, how large and chemically diverse are these oceans, and what energy sources sustain them? Why it matters, subsurface oceans are prime targets in the search for life beyond Earth. Poetic tie, hidden seas humming beneath frozen shells. What powers Saturn's hexagon and Neptune's storms? Saturn's persistent hexagonal jet stream and Neptune's massive changing storms are atmospheric oddities. The core unknown, what fluid dynamics, rotation, and thermal gradients maintain such structures? Why it matters, they test our understanding of atmospheric physics under exotic conditions. Poetic tie, weather sculptures carved in gas on a planetary scale. How were the irregular moons captured? Many planets have moons with unusual, tilted, or eccentric orbits, suggesting capture or violent histories. The puzzle, what capture mechanisms and early interactions produce these moon populations? Why it matters, the moon's histories are records of planetary migration and early chaos. Poetic tie, wayward stones stitched into a planetary family portrait. Where is the missing mass in the outer solar system? Observations show small discrepancies in orbital patterns and distant object distributions, leading to speculation about unseen mass. The open question, are these anomalies due to observational bias, distant planetary bodies, or collective gravitational effects?
Why it matters. Finding an undiscovered planet or understanding biases changes our map of the solar system. Poetic tie, a distant, dim companion hiding in the dark. 48. How did Earth get its water? Earth's abundant surface water may come from volatile rich asteroids, comets, or local chemistry in the early disk. The debate, what sources and processes delivered and retained most of Earth's water? Why it matters? It relates to planet formation, volatile delivery, and the origin of habitable conditions. Poetic tie, drops arriving like gifts in a cosmic mailbag. 49. How stable is the Oort cloud and its population? The Oort cloud, a hypothesized distant reservoir of icy bodies, is inferred from long-period comets but remains observationally elusive. The uncertainty: what is its true mass, structure, and how do stellar encounters and galactic tides shape it? Why it matters: the Oort cloud is the solar system's deep freeze and a record of early formation. Poetic tie: a distant attic where ancient comets sleep. 49. What produced the late heavy bombardment, if it occurred? Some planetary evidence hints at a spike in impacts early in solar system history, called the late heavy bombardment, but its existence and cause are debated. The question: were migration events, resonance crossings, or other dynamics responsible? Why it matters: the bombardment would have shaped early habitability and surface evolution. Poetic tie: a rain of rubble that repainted young worlds. We pause here on the threshold between rocks and life. The next block will carry us from the chemistry of worlds to the most intimate puzzle of all: how life begins. For now, let the planets turn in their slow orbits and the probes whisper their unanswered line, while we sit in quiet curiosity and watch the steady pageant of questions unfurl. 51. How did life begin from non-living chemistry? We see amino acids and simple organics form under plausible early Earth conditions, and experiments and meteorite analyses show many building blocks are common. The core mystery: what specific sequence of chemical steps assembled a self-replicating, metabolizing protocell out of that raw material? Why it matters: resolving abiogenesis would bridge geology, chemistry, and biology and tell us how likely life is elsewhere. Poetic tie: the moment when a quiet chemistry learned to keep a secret. 52. What was the first genetic system? RNA, DNA, or something else? RNA can both store information and catalyze reactions in laboratory settings, giving rise to the RNA world hypothesis. Yet many features of modern life rely on DNA and proteins. The unresolved point: which molecular system came first, and how did the transition to DNA protein-based life occur? Why it matters: knowing the first genetic chemistry shapes our search for life beyond Earth and for alternatives in different solvents. Poetic tie: the alphabet that first learned to spell itself. 53. Where did the building blocks of life come from?
Organic molecules are present in interstellar clouds, comets, and meteorites, and synthesis in early Earth chemistry is plausible. The question: what relative roles did local synthesis, delivery from space, panspermia-like scenarios, and geochemical concentration play in supplying amino acids, nucleotides, and lipids? Why it matters: tracing sources constrains the environments where life can plausibly start. Poetic tie: fragments carried on cosmic winds like letters for a nascent language. 54. How did the first cell membrane and metabolism emerge? Lipid-like molecules can form vesicles spontaneously, and simple energy-harvesting chemistries operate in hydrothermal vents, but integrating a stable membrane with sustained metabolic networks remains unclear. The mystery: how did membrane compartmentalization and energy flows organize into self-sustaining protocells? Why it matters: this step is critical to moving from chemistry to life and shapes early ecological possibilities. Poetic tie: a fragile skin that learned to hold itself together against the world. 55. What role did mineral surfaces and hydrothermal systems play? Some experiments suggest minerals or vent chimneys concentrate reactants and catalyze complex chemistry, and deep-sea vents offer steady energy gradients. The uncertainty: were such geochemical settings the cradle of life, or did shallow pools and tidal cycles play the dominant role? Why it matters: identifying plausible cradles directs exploration on icy moons and exoplanets. Poetic tie: rock and heat conspiring to kindle the first slow fires. 56. Are viruses ancient relics or later inventions? Viruses occupy a strange place between chemistry and cellular life. Some are simple, others carry genes with unknown origins, and viral fossils are found integrated in genomes. The question: did viruses emerge before cells, co-evolve with early life, or arise repeatedly as genetic parasites? Why it matters: their origins inform the evolution of complexity and horizontal gene flow. Poetic tie: shadow weavers threading genomes with borrowed patterns. 57. Could life arise with different biochemistries?
Life on Earth uses water as solvent and carbon-based chemistry, but theoretical models propose solvents like liquid methane or alternative backbones like silicon-based chains as speculative possibilities. The issue: which chemical frameworks can support stable information storage, metabolism, and compartmentalization under realistic conditions? Why it matters: broadening the chemistry of life expands the landscapes where astrobiology should look. Poetic tie: unfamiliar seas where strange languages might develop. 57. How common is habitable chemistry on exoplanets and moons? Telescopes like James Webb and ground arrays detect molecules in exoplanet atmospheres and characterize disks, revealing diverse planets and potential habitable zones.
The core unknown. How often do worlds combine stable liquid, energy fluxes, and chemical richness long enough for life to begin? Why it matters: it refines estimates of life's frequency in the galaxy and prioritizes observational targets. Poetic tie: distant shores where warm tides might lap at new beginnings. 59. What makes an environment truly habitable versus merely benign? Habitability is more than just the right temperature. Factors like planetary geodynamics, magnetic fields, tidal heating, atmospheric stability, and nutrient cycles matter. The question: which combination of these factors is necessary and sufficient for life to start and persist? Why it matters: distinguishing marginal from robust habitability helps interpret biosignatures and mission planning. Poetic tie: not every welcoming bed is a cradle. Some only offer passing comfort. 61. Can we detect definitive biosignatures remotely? Telescopes can identify gases like oxygen, methane, or complex organics in exoplanet atmospheres, and missions can sample plumes from icy moons, but false positives exist from abiotic chemistry. The mystery: which combinations or time-varying signals constitute incontrovertible evidence of life, and how confident can we be at interstellar distances? Why it matters: a reliable biosignature would be the first direct answer to whether life exists beyond Earth. Poetic tie: faint echoes of living fires carried across the dark. Leaving the chemistry and seas of other worlds for a while, we move into the living realms on Earth, where biological form, aging, and resilience still puzzle us deeply. 61. Why do organisms age at different rates? Species show wildly different lifespans. Tiny mayflies live days, while bowhead whales live over a century, with cellular maintenance and repair varying accordingly. The unresolved point: what combination of genetic, metabolic, and ecological pressures set species-specific aging programs and limits? Why it matters: understanding these mechanisms clarifies evolution's trade-offs without promising simplistic cures. Poetic tie: clocks wound in different gears across the tree of life. 62. What determines maximum lifespan in nature? Some organisms seem effectively ageless under certain definitions, while others have strict lifespan ceilings. Telomeres, stem cell decline, and metabolic damage are implicated. The central question: are there hard biological ceilings to lifespan, and how much is determined by evolution versus physiology? Why it matters: this frames responsible expectations about longevity research and the biology of maintenance. Poetic tie: a species' life like a candle of varying wax and wick. 63. How do certain animals regenerate complex tissues? Salamanders can regenerate entire limbs, and some fish replace organs. Mammals are generally more limited in regenerative ability.
The mystery: which genetic programs and cellular contexts permit such full regeneration, and why were they lost or suppressed in other lineages? Why it matters: learning these principles reveals evolution's flexibility and could inform regenerative medicine cautiously. Poetic tie: bodies that script new chapters where pages were torn away. Why do large animals rarely get cancer proportionally? Known as Peto's paradox, species with many more cells do not show proportionally higher cancer rates, suggesting enhanced cancer suppression mechanisms in large, long-lived animals. The unknown: what specific genetic or cellular systems evolved in whales, elephants, and others to keep cancer rates low? Why it matters: comparative biology offers clues to cancer defense without overpromising therapeutic panaceas. Poetic tie: giants that carry many cells under an uncommon watch. How do microbiomes shape health and evolution? Communities of microbes live on and inside animals and plants, influencing development, immunity, and even behavior. The open question: which microbial interactions are causal for complex traits? How stable are these relationships, and how did they co-evolve? Why it matters: microbiomes are vital ecosystem components and complicate simple organism-level narratives. Poetic tie: unseen gardens tending the visible forms. What limits biodiversity and drives extinction risk? Species diversity reflects evolutionary history and environmental niches, yet extinction rates vary with climate, human pressure, and random events. The mystery: how do interacting pressures, Habitat loss, climate shifts, disease, and invasive species combine to push systems past tipping points. Why it matters. Predicting and preventing extinctions depends on teasing apart these interacting causes. Poetic tie. A web with some threads frayed and others reinforcing the whole. How do organisms maintain robust circadian rhythms? Molecular clocks synchronize physiology to day-night cycles and seasonal cues, seen across life from cyanobacteria to humans. The question, how do internal clocks scale with ecology and physiology, and why do disruptions cause widespread effects? Why it matters. Clock biology links behavior, metabolism, and health across scales. Poetic tie. Internal sundials, keeping time in bodies that wander in time. What controls phenotypic plasticity and developmental noise? Genetic programs produce robust forms, yet the same genotype can yield different outcomes under varying environments, and random fluctuations matter too. The unresolved point. How do developmental systems buffer noise while allowing adaptive flexibility? Why it matters. This shapes evolvability, resilience, and species responses to changing habitats. Poetic tie. One recipe yielding many flavors, depending on oven and spice. How is complexity built by evolution without foresight?
Complex organs and behaviors arise through incremental selection, but the pathways are many and contingent. The question, which constraints and historical accidents steer lineages towards complexity rather than simplification, and how repeatable are such outcomes? Why it matters? It illuminates the balance of chance and necessity in life's tapestry. Poetic tie, slow embroidery, stitched by invisible hands of time. 70. What governs the emergence of eusociality and cooperation? Eusocial systems like insect colonies or cooperative breeding in vertebrates require extreme altruism and division of labor. The mystery, under what ecological and genetic conditions does such cooperation evolve and remain stable? Why it matters? Answers inform social evolution theories and the roots of human cooperation without simplistic analogies. Poetic tie, many voices learning to sing one song. From cells and species to the mind's hush, the next block carries us inward, to brains, memory, and the strange subjective textures of being. 71. What is consciousness and how does it arise? Neuroscience maps correlated brain activity with reports of awareness, and theories like global workspace and integrated information offer frameworks, yet the hard question remains. The central mystery, which physical processes suffice for subjective experience, and is consciousness graded or binary? Why it matters? Resolving this reframes ethics, cognition, and how we model minds. Poetic tie, the quiet light that turns sensation into inner weather. 72. How are memories encoded, consolidated, and retrieved? We can observe synaptic changes, replay during sleep, and systems-level reorganization, but the precise mechanisms that stabilize long-term memory and reconstruct past events are complex. The unknown, how transient molecular events become persistent, malleable memories, and why some memories persist while others fade. Why it matters? Understanding memory mechanics illuminates learning, trauma, and the aging brain. Poetic tie, impressions stored like tides in a mind's shore. 73. Why do we dream, and what function do dreams serve? Dreaming involves characteristic neural patterns during sleep stages and is nearly universal in mammals and birds, yet theories range from memory processing to emotional simulation. The question, are dreams essential for cognitive maintenance, emotional regulation, or merely byproducts of neural activity? Why it matters? Dreams may reveal how brains simulate worlds to rehearse or consolidate experience. Poetic tie, nightly rehearsals of a private theater. 74. How do emotions arise and guide decision-making? Emotions link bodily states, neural circuits, and appraisal systems to influence choices. Classical and contemporary theories map many pathways. The unresolved point, how discrete emotions integrate with cognition across contexts and cultures, and how they evolve to shape adaptive behavior.
Why it matters. Emotional mechanisms are central to social life and mental health. Poetic tie, currents beneath calm waters shaping the boat's drift. What underlies creative insight and originality? Creativity involves associative thinking, memory recombination, and motivated exploration, with brain networks like the default mode implicated. The mystery, what neurocognitive processes spark novel, useful ideas, and why do they vary so widely between individuals and moments? Why it matters? Understanding creativity could nurture innovation responsibly without reducing art to mere algorithms. Poetic tie, a sudden filament that connects distant stars into a new constellation. How is subjective time perceived, and why does it vary?
Time perception stretches and compresses with attention, emotion, drugs, and neurological conditions, implicating distributed neural timing mechanisms. The question, what neural clocks or patterns yield our felt sense of duration and order, and how are they calibrated? Why it matters? Time perception shapes behavior, learning, and the experience of self. Poetic tie, elastic threads that let moments lengthen like late afternoons. How are neural bases of free will and agency? Many brain studies show unconscious preparation before reported decisions, but people still experience choice and responsibility. The core mystery, how does neural processing produce the felt authorship of actions, and what are the limits of that agency? Why it matters? The answer informs moral responsibility, legal thought, and how we talk about human choices. Poetic tie, a small hand steering a ship in a sea of currents. How do brains represent abstract concepts and symbols? Language, mathematics, and culture rely on symbols that transcend immediate perception, yet the brain's coding for abstract categories is distributed and flexible. The question, what neural formats reliably encode abstractions, and how do brains generalize across contexts? Why it matters? This connects cognition, learning, and artificial intelligence research. Poetic tie, scaffolds of meaning rising from delicate neural scaffolding. How do brains remain plastic yet stable across life? Neural circuits must learn and adapt while preserving key functions, balancing synaptic turnover with long-term architecture. The unresolved point, what mechanisms set the window and degree of plasticity across developmental stages and in adulthood?
Why it matters. It informs education, rehabilitation, and recovery after injury. Poetic tie, living clay that hardens without turning to stone. The next block shifts to animal navigation, migration, and astonishing journeys that species undertake across the planet and beyond. 81. How do animals sense Earth's magnetic field? Many migratory species, including birds, turtles, and some bacteria, use a magnetic sense to navigate, with molecular and neural candidates proposed. The mystery, what receptors and neural computations convert geomagnetic cues into reliable directional information across noisy environments? Why it matters? Decoding magnetoreception opens bio-inspired navigation and deepens our view of sensory diversity. Poetic tie, invisible maps whispered into tiny compasses. 82. How do monarchs and other insects navigate across generations? Monarch butterflies traverse thousands of miles, relying on seasonal cues and inherited navigation, yet the precise mix of genetic programming, environmental calibration, and learning is debated. The question, how is migratory instructions encoded and updated across life stages and generations? Why it matters? It informs conservation and our sense of inherited behavior. Poetic tie, a relay race where the map is passed, not learned anew. 83. How do animals imprint and learn migratory routes? Many species follow learned routes aided by landmarks and social transmission, but the balance between innate maps and experiential learning varies by species. The core unknown, which memory systems and social mechanisms preserve and transmit long-distance paths across individuals. Why it matters? It reveals cultural transmission beyond humans and helps predict responses to habitat change. Poetic tie, footsteps echoing between elders and their young. 84. How do marine animals navigate the open ocean? Whales, turtles, and seabirds cross featureless seas using combinations of celestial cues, chemical gradients, currents, and possibly geomagnetism. The unresolved point, how are multimodal cues integrated into robust navigation over vast, changing oceans? Why it matters? Understanding navigation aids conservation of migratory corridors. Poetic tie, ancient sailors reading an ocean written in currents and cues. 85. How do animals coordinate in large groups? Flocking birds, schooling fish, and migrating herds exhibit synchronized movement without centralized control. Local interaction rules are implicated but complex. The question, what simple rules and sensory thresholds scale into emergent collective behaviors across densities and environments? Why it matters? Collective dynamics inform robotics, crowd safety, and ecology. Poetic tie, many threads woven into a living tapestry. 86. How do homing pigeons find home so reliably? Pigeons use multiple cues, visual landmarks, olfactory signatures, and magnetic inputs to return home over long distances, yet the dominance and integration of these cues vary by context.
The core mystery. How do pigeons weight conflicting cues and maintain route fidelity in unfamiliar terrain? Why it matters? It reveals sensory hierarchies and robust navigation strategies. Poetic tie, a compass of sense and sights stitched into memory. 87. How do animals sense environmental change and adapt migration timing? Many species shift migration timing in response to climate-driven phenology changes, sometimes dissynchronizing from resource peaks. The unknown, how flexible are migratory programs genetically and behaviorally, and what are the consequences of mismatch? Why it matters?
It shapes species' resilience to rapid environmental change. Poetic tie, a calendar rewritten by warming seasons. 88. How do nocturnal migrants find stopover and feeding sites? Many migratory birds travel under cover of night, using stars and other cues, and must locate suitable refueling sites en route. The question, how do they find and remember scarce stopover habitats in changing landscapes? Why it matters. Protecting stopovers is crucial to conserving migratory populations. Poetic tie, dark travelers pausing at scattered lamplights. 89. What mechanisms underlie animal long-distance memory? Some species recall locations of caches or seasonal food sources across years, pointing to robust spatial memory systems. The mystery, what cellular and circuit-level strategies store and retrieve precise geospatial memories over long intervals? Why it matters. It informs cognition and species survival strategies. Poetic tie, a pantry of remembered places folded into a creature's mind. 90. How will fragmentation and climate change reshape migration corridors? Human land use and shifting climates alter the paths and viability of migrations, sometimes creating new barriers and novel hazards. The unresolved point, how will species adapt routes, timing, and population structures when traditional pathways become disrupted? Why it matters. Predicting outcomes guides conservation planning and mitigations. Poetic tie, old roads closing and new pathways sketched in uncertain ink. We now return to the planet that hosts us, Earth, its deep processes, cycles, and the mathematical ideas that undergird our attempts at understanding. These final questions widen toward meta-issues about knowledge itself. 91. How do plate tectonics start on Earth? Plate tectonics now reshapes continents, recycles crust, and drives volcanism, but the initiation mechanisms in early Earth remain debated. The core mystery, what thermal, compositional, and mechanical conditions triggered sustained plate movement rather than a stagnant lid? Why it matters. Early tectonics set the stage for climate evolution, nutrient cycles, and habitability. Poetic tie, the planet learning to rearrange its own skin. 92. Where did Earth's water ultimately come from? We know Earth has abundant water, and isotopic studies point to contributions from various sources, but precise proportions are debated.
The question, what fraction came from local volatile-rich planetesimals, comets, or chemical processing within the disk? Why it matters. The provenance of water ties planetary formation to the emergence of oceans and life. Poetic tie, raindrops that remember journeys from far-off reservoirs. What causes magnetic field reversals and their timing? Earth's magnetic field flips polarity irregularly across geological time, leaving magnetic signatures in rocks, but the dynamo processes and triggers remain incompletely understood. The mystery, what internal dynamics set reversal frequency, duration, and intensity? Why it matters. Reversals affect cosmic ray shielding and can inform planetary dynamo theory. Poetic tie, a compass swinging its head like a restless sleeper. What triggered past mass extinctions and their selectivity? Some mass extinctions align with impacts, volcanism, and climate perturbations, yet causes and species-specific vulnerabilities vary by event. The unresolved point, how did combinations of stressors interact to produce rapid biodiversity losses, and why did some clades survive while others vanished? Why it matters. Lessons from the past inform resilience and tipping points in the present. Poetic tie, sudden curtains falling on ecosystems that once sang. Why does mathematics so effectively describe the physical world? Mathematics maps physical laws with uncanny precision, from orbits to quantum amplitudes, yet the reason for this unreasonable effectiveness is debated. The central question, is math discovered as an external structure, or is it a human-constructed language tuned to patterns the universe presents? Why it matters. Understanding this relationship touches on epistemology and how we build scientific models. Poetic tie, numbers like keys unlocking doors in a hidden architecture. Is randomness fundamental or emergent in nature? Quantum mechanics posits inherent randomness in measurement outcomes, while statistical randomness often emerges from underlying deterministic laws at larger scales. The mystery, does irreducible randomness exist at the deepest level, or will a deeper deterministic description someday remove apparent chance? Why it matters. This affects predictions, free will debates, and interpretations of probability in science. Poetic tie, whether dice are truly cursed or merely too complex for human sight. Are the laws of mathematics and physics the same everywhere? We assume physical laws are universal, and mathematics is constant, but some cosmological models allow local variation in constants or structures. The question, are the forms of mathematical truth and physical law invariant across possible domains, or do they depend on context? Why it matters. It probes whether science uncovers absolute truths or useful models for accessible regions.
Poetic tie, whether rules are carved into a single stone or rewritten in different rooms.
Can we, in principle, know everything about the universe? Practical limits, horizons, quantum uncertainty, chaotic sensitivity restrict measurement, and Gödel-like results hint at formal limits to some systems. The unresolved point, are there principled, insurmountable epistemic limits that prevent certain cosmic facts from ever being known? Why it matters, it frames humankind's aspirations and humility in the face of forever closed doors. Poetic tie, windows with fogged panes that we polish but never clear completely. What is the ultimate origin of the laws themselves? We write equations describing how things evolve, but the meta-question remains, why these laws in this form, and could a deeper principle determine them? The core mystery, are laws emergent from underlying realities, selected by anthropic or cosmological processes, or brute features of a deeper ontology? Why it matters, it probes the foundations of explanation and whether science can reach a final story. Poetic tie, the grammar behind the universe's ongoing sentence. Will we ever reach a final, complete understanding? Science progresses by refining models, expanding observations, and revising frameworks, but history shows that each resolved puzzle tends to reveal deeper questions. The ultimate issue, is there an endpoint to inquiry, an exhaustive theory of everything, or will understanding be an endless horizon that keeps receding as we approach? Why it matters, this question shapes the soul of science as a practice of perpetual curiosity rather than conquest. Poetic tie, a path that stretches into dawn, inviting us forward rather than promising a last gate. We have arrived at the end of our 100 quiet probes, each a doorway to more work, instruments, experiments, and thought. Some of these questions point to telescopes like James Webb, LIGO, or instruments such as Planck and Cassini. Others call for new laboratory techniques, sample return missions, or fresh mathematics. Many are empirical, things we can hope to measure more precisely, while some are conceptual, asking how we must change our thinking to see more deeply. Before we close, a soft invitation. If you love drifting through questions like these, consider subscribing or liking to join the patient search and to keep company with slow curiosity. It's a small way to return to this quiet observatory again. Tonight, the unanswered list is not a catalog of failure, but a treasury of invitations. Each item reflects how much we have learned and how much remains to be explored. Telescopes that will stare deeper, probes that will skim icy plumes, colliders and detectors that will press at nature's seams, and minds that will imagine new frameworks. The history of science shows that questions often breed other questions, and that surprises lurk where careful observation meets bold idea. To live amid unknowns is not to be lost, but to be at the edge of possibility.
So let these 100 mysteries be company as you turn a page or close your eyes. Think of the universe as generous, offering clues, puzzles, and instruments to help us listen. Some answers may arrive in our lifetimes, many will be passed down like lanterns to future generations, and others may keep their distance forever, serving as gentle reminders of humility and wonder. Good night. May your thoughts drift among quiet constellations of curiosity, and may your dreams be full of wonder. If this night of questions left you curious, watch our deep dive playlist on specific themes, or subscribe for more calm explorations. Sleep well.